I started recording. I have no idea how many people are on the stream right now because I can't see any metrics. But that is fine. I don't really. So the plan is I'm just going to be going through the documentation. I'm not really. This is not really a tutorial as such. This is me reading the documentation of PostgreSQL. This is something I wanted to do for quite some time. And yeah, this should be fun. I don't know how. So the timeline I had an idea was around 8 o'clock. I'm 40 minutes late. Apologies, but I want to do this more or less for the next 36 hours. I'll be taking breaks in between to sleep, eat, and stuff. But this is the general idea that I had. This is something I wanted to do 2 years ago, actually, with a friend. But yeah, I am going to do this alone right now. So here goes nothing. If any of you have a Twitch account, it'll actually be nice if you can join the stream chat if you have any questions. But otherwise, yeah. Cool. So this essentially has my plan. My Notion page has my plan, and I'm going to be right now. I'm starting the preface. It should not be too much, but I'm going to read almost every section of it. There are a few sections that I do not want to read or do not have time to read. If you go to my notes and if you look at this, you will see that I have some which are not in scope. I'm not going to be tackling anything which is on Windows. I'm not going to be tackling any of the extra modules which are around TCL, TK or Perl. I will do the Python module at least for the sake of it. But even the appendices, it depends, all the rest of the stuff. But more or less, I should be going through most of the documentation. So here goes. The first section is what is PostgreSQL. I do not need the terminal right now. Cool. The reason I'm starting this is a friend once told me that the Postgres documentation is one of the most impressive pieces of documentation there is. Out of curiosity, I've read it once. I've not read the entire thing end to end. I've read portions of it whenever I needed it. I've read the administration section about once or twice, installing from source and everything. So yeah. So cool. So I'm going to read 13.3. I'm not going to read the development version. So, and neither am I going to read one of the older versions. I'm just going to read the current one. I'm not going to read most of it out loud though. So yeah, this is all the normal. This just explains the logistics, which more or less the same stuff that I have in my course. You have 4 parts. You can treat part 2 actually as a SQL tutorial. It's actually pretty nice. You should. It doesn't even matter if you're a Postgres user or not. You just go into this, you learn SQL. But the rest of this, the actual administration of it is really nice if you're learning to deploy it. The part 5, 6 and 7 are really, really nice in that they teach you the internals of the language, of the server. So cool. PostgreSQL is an object relational database management system. Yeah, it's based on. So there is actually I don't know how many people know this, but there is a paper which was published a long time ago which explains what Postgres is. So this is the old version. The university, I think this came out of Berkeley. So this thing was being maintained in 1994, but now that's it. It's not really being maintained. These are all old versions. You can go through the paper and everything, but this is something very interesting. Like the paper which was used to define what Postgres was written back in the 80s and 90s, and it's very interesting. So you have, this is the open source descendant of the original Berkeley code. It supports a large part of the standard, and yeah, it has more features. It has multiple modern features, and it can be extended by adding new. Can be extended by more or less anyone. You can do data types, functions, operators, aggregate functions, index methods, and procedural languages. By the way, I'm not going to pretend anyone knows what any of these are, because I don't know what most of them are. I mean, of course, I know what data types are, functions are, and other stuff, but what do you mean when you could say you can introduce a new procedural language? Maybe Lua? Oh, hopefully. Let's see. So yeah. So like I said, you originally had the Postgres project. So yeah, I'm going to start reading this silently for the most part because I want to get most of this in, and I read pretty fast. So if you have, I can post this section in the chat. So if anybody is interested, this is what I'm reading. Look at this. Shown in the 1988 ACM Sigmod conference. So this, I think this is the paper that I was originally telling you guys about. You have partial indexing in Postgres. This was a research project in the 90s. Then you also have the Postgres data model. Oh yeah, here you go. You have this paper, the design of Postgres. This is something I was reading a while ago. So this is really interesting. Yeah, this one, 95. So this paper actually explains how Postgres was originally created, the grammar that they had, and everything. I'm not going to read this because I'm going to fall asleep if I read this right now. I'm not in a position to read something this technical. Maybe later. The references are actual stuff that you should read if you want to learn more about databases. I would recommend it to anyone who wants to write their own database actually. Has anyone ever thought about that? I once wanted to write a database. I still do, eventually, in Rust. I want to just write a SQL compliant database in Rust, not for anyone else, just for myself, for fun, not really a thing, as an exercise. Cool. 97, version 3 appeared in 1991 and added support for multiple storage managers, improved query extractor and rewritten rule system. For the most part, Postgres has been used to implement many research and production applications. Financial, jet engine, you don't really need examples of what Postgres was used for. But this is the original Postgres, not what we know as PostgreSQL. PostgreSQL. So yeah, version 4.2, the project ended. In 1994, had a SQL language. So, this is interesting. So the original thing did not even have a SQL language interpreter to this. So you had Postgres 95. 95 was the NSIC, trimmed by 25%, internal changes improve performance, maintainability, 30 to 50% faster on the Wisconsin benchmark. Speaking of which, what is the Wisconsin? I don't want to. Interesting. Okay, it's a benchmark for relational databases and machines. Nice. Not going down that rabbit hole. The query language for PostgreSQL was replaced with SQL. So you had a specific. Okay, so this is what. So this PDF that I had open. Wait a second. When I have that. Yeah, this thing. This thing defines PostgreSQL. It doesn't define SQL. That's what it is defining. It's not essentially. So it's the design of Postgres with. Nice. So this is not even the SQL compliant business. So it has nothing to do with that. Subqueries were not supported until PostgreSQL, but they could be imitated in Postgres 95 with user-defined SQL functions. Aggregate functions were re-implemented. Support for group by query calls was also added. How excited do people get about Postgres? That's very funny. So you have a new program. PSQL was the command line tool, which used GNU readline. Okay, that makes sense. It had a previous monitor program. We had a front-end library called libpgctcl for TCL clients, TCLSH. Inversion large objects were the only mechanism for storing large objects. The instance level rule system was removed. Rules were still available as rewrite rules. A short tutorial introducing regular SQL features as well as those of Postgres 95 was distributed with the source code. GNU make instead of B. Good for them, but GNU make is not really the way to go. Postgres 95 could be compiled with an unpacked GCC. Data alignment of doubles was fixed. And whoever wrote this seemed really excited that all of this got fixed. So PostgreSQL. By 1996, it became clear that the name Postgres 95 would not stand the test of time. We chose a new name, PostgreSQL. Okay. To reflect the relationship between the original and the more recent versions with SQL. At the same time, we set the version numbering to start at 6.0. Putting the numbers back into the sequence originally begun by the Berkeley project. So what did this thing do? I think, okay, so this went the way of 95 and everything, so they assumed this was 5. Postgres 5 and this is Postgres 6, which became the PostgreSQL. Because of tradition and it's easier to pronounce. Yeah, sure, it is definitely easier to pronounce. The emphasis is cool. Details is what has happened. If you want more details, you have it in the appendix. I'm not reading that. So you have the conventions. So brackets, square brackets indicate optional parts. TCL command, not interested. You have braces and vertical lines indicate that you must choose one alternative. Dots mean that the preceding element can be repeated. Nice. Where it enhances the clarity, SQL commands are the prompt and shell commands are preceded by the dollar. Normally prompts are not shown though. An administrator is a person who is in charge of installing and running the system. A user could be anyone who is using or wants to use any part of the Postgres system. These terms should not be interpreted too narrowly. Wow. I mean, nice. It does not have any fixed presumptions about system administration procedures. This guy knows his database admins. Further information, you have a wiki, you have a website, mailing lists, and us. Not me in personal though. Do not point your Postgres bugs at me, please. Yeah, bug reporting. This thing. I wonder if I'll find any bug in the documentation while reading this. When you find a bug in Postgres, we want to hear all about it. Your bug reports, yada 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 yada. Where? I'm pretty sure these guys don't use GitHub. They use something else. Check the to-do list. What do you report? You report. Don't say, don't report speculation. This is all the common sense stuff that you have. Well, I should not assume it's common sense, but open source this thing. By the way, a lot of, see, if you read this, you'll realize that Postgres also has a startup file. It has a setting file called psql.rc. There are actually conference videos telling people that this is there, but I didn't have to go too far into the documentation. I mean, I read this for about 10 minutes, and I already found out that this was there. I encountered this, the first time I saw this was in someone's PostgreSQL prompt customization. I think it was using Powerline along with Postgres. Alright. Don't say, naturally. Increase your verbosity, you increase your log error verbosity, you do all of that, then submit everything. You can also check the version of Postgres. Cool. Where do you report bugs? This is where you report bugs. You have a mailing list. You have a bug report at the you have a website. At the website there's a bug report form. Cool. You also have, do not send any mailing list to the user mailing list like PGSQL SQL lists or PGSQL general or PGSQL hackers. Wow. PGSQL docs. Yeah, this is, if you have a problem with the documentation, this is where we are going to mail them. If I have a problem. Alright. If your bug is a portability problem and a non-supported problem, yeah, makes sense. Cool. Part 1. So, this section is installation, architectural fundamentals, accessing a database, creating a database, the SQL language, advanced features, everything. Nice. Getting started. So yeah, the getting started section, it's about installing it. Fun fact, you have to jump to chapter 16. it's, you don't really have to do this. Like, you don't have to install the server to follow along. You can just read the documentation as if it is some fun exercise in reading, but you should install it probably. I'm going to jump ahead to chapter 16 because that's where you install either from the source code or you install from this thing. I am going to install from source code. I'm not going to install it from this thing. So yeah, the short version. You have to get the source code though. Where is, in the short version it gives you the commands to run, but we're not going to do that. We're going to look at the requirements. So here's the thing: if you have to install Postgres from source, you have a few things to do. Alright. So you need make version. So 4.3 obviously. It needs at least 3.8. You need an ISO NSIC C99 GCC. So GCC hyphen version. Cool. You need tar. Right, I have tar. You need readline. Sudo pacman. I use Manjaro by the way. So installed. Yeah, it's installed. I have the readline library. If you don't want readline, you can install it, but you will not get the PSQL command line tool. So, so you also need zlib. Cool. You have I have zlib installed, obviously. Yeah. To build the Perl, this thing, you need Perl, including libperl. Perl is installed. Libperl is not installed. I think libperl is already there. It's called glibperl, so no, that's pretty sure it should be installed by default. Nah, that's okay. So you need the libpython library. I'm pretty sure I should have this because my Python installation is up to date. So you need Python 2.6, but Python 3 is supported if its version is 3.1 or later. But C section 45.1 when using, I'm not going to do that. I don't care about TCL, native language support, program other than English, I don't need that. If you need OpenSSL, if you want to support encrypted client connections, OpenSSL is also required for, let me see if I have OpenSSL, I should. I have. So, it is installed. So here's the fun part. You need Git. I have Git, but yeah. So you need Flex and Bison. You need to get Flex version 2.3 and Bison. So you have other Lex and Yak programs. They cannot be used. So yeah. Sudo pacman -si ss flex. I think. I think the package name for Flex is something else. Ah, Flex and Bison. Yep. I mean, if you're curious about what Flex and Bison are, you need all of these for the tokenization, for scanning, and for basically interpreting the grammar of PSQL. So you need Perl is needed to build from a Git checkout, or if I've already checked Perl. If you're building on Windows, you will need Perl in any case. I'm not going to cover Windows here. So if you need to get a GNU package, you can find it in your mirror. You need about 350 MB space. Yeah, cool. So yeah, now getting the source. Let's get the source. You can download either from the version control repository, or you can download it directly from the thing. So I'm going to get it from the version control repository. Getting yeah, let's get the source code from Git. Ah, cool. PostgreSQL. Cool. How do I build it now? Ah, geez, this is going to take a while. Installation procedure. Configure, make the build directory, and you I mean, the commands are fairly straightforward. You have to configure. If you want it for, you want to set it up as a default installation, you just do that. You'll check your dependencies and everything. You can also install it outside the source tree and build there. If you want to keep the build directory separate from the source files, so you just run, you make a build. I'm going to do this. I'm going to make a separate build directory and I'm going to install everything there. So you'll have everything, and all the files will be installed under /user/local/pgsql by default. I'm going to keep this, but you can change all of this by changing the by either customizing the configure command or by changing the configure script. You can do that. So if you want to install somewhere else, if you have any space problems. So right. So /PostgreSQL configure. Let's check what this file has. So guess this had something wherein it had a section where slash user slash bin had such a section here somewhere. Dot slash PostgreSQL configure. Cool. I tried doing this on a Raspberry Pi 0 once. It took about 4 hours. Was not fun. I'm hoping it'll be much faster on this. All hail the Ryzen 7. Wait. I should not have done this here. I should have made a... I'm going to do it again. I'll remove those files later. Cool. 12 seconds. So here make it says the build will take a few minutes depending on your hardware. It took 4 hours on Raspberry Pi 0, so we see how long it takes. This is charged. What do I do next? I mean, there is also the other way of installing Postgres, which is like use your package manager or download. Yeah, I mean, that would have been a much easier exercise, but I don't want to do the easy way. I'm going to keep this open, so I'll keep reading the other parts while this is happening. That saves time. Besides, I don't have to do this way. I'm going to use the short version for all of this. So Here we go. But until then, I'm going to go back to the previous version that I was reading. Installation. Yeah. Oh, it installed. Let's see. Okay. Install. Oh, it's already installed. Oh. Ah. Cool. So, add user, Postgres. Ah, it's not add user, sudo. Is it user add? Add user is a. This is what you use for this thing. Is there an add user command? I've never seen a add user. Please tell me I didn't find a bug in the Postgres documentation. Yeah, there is an add user command. I think. Yeah, it's much more interactive as compared to the user add command. Great. It's fun knowing that I don't have that command. Make dir slash user slash local slash pg SQL slash data. Chhow. Oh. Sudo bang. No. Slash user slash local slash pg SQL slash data. Sudo Postgres slash user slash local slash pg SQL slash data. User. Yeah. So next, su hyphen Postgres. Sudo slash user slash local slash pg SQL slash bin slash initdb hyphen d slash user local pg SQL data. Cool. Use this command. Wait, what happened? Yeah. I didn't want to do that with sudo. But sudo mid hyphen slash home slash Postgres. Sudo mid slash home slash Postgres. Sudo chmon Postgres slash home slash PGCTL could not start. What's happening here? Yeah, it still says there is a permission error, so I probably need to. Could not change directory to. Oh. Interesting. Is it because the build directory is in. Because the build. Aha. cd build directory. Sudo chmod a plus r rxw. Shouldn't be doing this, but yeah, sure. No. Could not change directory to. Why is this failing? Slash home slash what am I missing? I mean, sure. I mean, I can create something. Is it because it couldn't? Yeah, it didn't have permissions to create files in that folder, that's why it failed. chmod a-rwx Okay, I have. Let's create a test database. Let's create a. Oh, sorry. Cool. Yeah, cool. You have stuff. Great. That's some progress. I'm back here. I've installed everything, and now to the architectural fundamentals. Cool. Yeah, Postgres uses a client-server model. It consists of the following cooperating processes. You have a server process and you have a client process. The server process manages the database files, accepts the connections to the remote to the database from client applications, and performs database actions on behalf of the clients. The server program is called Postgres. And then you have a client, some front end. It's a CLI or a graphical application, web server, whatever, what have you. So the client and server can be on different hosts, obviously, and they can connect over a TCP/IP network connection. You should remember this because the files that can be accessed might not be accessible on the database server machine. So the Postgres server can handle multiple concurrent connections from it forks a new process for each connection. From that point on, the client and server process communicate without intervention by the original Postgres host. Ah, nice. Cool. Creating a database. The first test is to see whether you can access the database servers and try and create a database. A running Postgres server can manage many databases. Typically, a server database is used for each project. Cool. Create DB, my DB. Yeah. So, if you see this error, you're not in the Postgres prompt. You're in just that. So, no, sorry. Create DB. You can't. Yeah, I can't use create DB directly. So, because I've not added that part to host that part to my system path. So. Cool. Now, the errors you might get are either you could not connect to it, the server is either not running, or maybe it is on a different host, whatever. So you have to create a different. You can't use your login ID unless you've created a user with that login ID, and yeah. So you have all of this. If you don't have access to create a database, then you will see that you cannot create a database. Not every user has the authorization to create new databases. If Postgres refuses to create databases for you, then the site administrator needs to grant you permission to create databases. Contact, sure. You can also create databases with other names. Postgres allows you to create any number of databases at a given site. Database names must have alphabetical first character. Wait, what? I didn't do that. But still. This is weird. Is that a standard? And are limited to 63 bytes in length. Is to create the same name as your current username. Many tools assume the database name is as the default, so it can save you some typing. To create that database, simply type create DB and it will create a database with your username. And you can also say drop DB and that's it. So yeah, cool. You have all of this. This is actually interesting. So if you go up, where was this? Yeah. If you install Postgres yourself, you should log in for the purposes of this tutorial under the user account that you started the server as. So Postgres usernames are separate from operating system user accounts, but sometimes the names are the same. So as long as you can SSH into a machine, you can connect to your appropriate account as long as you have an account in the Postgres server. So as it happens, there will always be a Postgres account that has the same name as the operating system user that started the server, and it also happens that the user always has permissions to create databases. Instead of logging in as that user, you can also specify, you can give /u to connect as a specific user account, accessing a database. Once you've created a database, you can access it by running the PostgreSQL interactive terminal program, PSQL, which is what I have done now. Yeah, you also have other stuff. One of my favorite tools is actually PGCLI. PGCLI is slightly different, but it is, this thing. It has IntelliSense and it has nice formatting, it has autocomplete. So I will not use PGCLI right now, but I might use it later if I get tired with using PSQL. So yes. Back to this. If you do not support the database name, it will default to your user account name. Yeah, you saw this. So in PSQL, you will be greeted with the following message. Type help for help. Very good. Which I saw here. And yeah, the last line could also be this. But this, it's either this or this. The pound or the hash means that you are a database super user if you install it. If you encounter problems starting PSQL, go back, diagnostics, the last line is the prompt. Alright, so let's check the version. There is some problem with my end. Yeah, you have to use a semicolon. PostgreSQL 15 Devil. 15? Oh, so yeah, while I'm reading the documentation, I did pull from version control, so I did pull Postgres version 15, which was in hindsight, that was a mistake. Good to know. I'll see. We'll start seeing what problems I have with this. By tomorrow, I'll switch back to the older version of Postgres and reinstall it. But for now, I'm going to continue. I'm not wasting time with this. But select current date. Cool. It has some internal problems, commands which are not SQL commands. They begin with the / command. You can now access /h help, and you can get out by /q. Cool. And yeah, and you want to know more internal commands, /? You have half of that. Yeah, nice. Formerly known as Postgres, then as Postgres 95. Really nice. Will not use these features, but you can use them yourself whenever it is helpful. Now, chapter 2, the SQL language. I didn't have to make many notes, to be honest, for these chapters, so I'm not going to. In retrospect, if I ever come back to it in the following weeks, I will go ahead and add notes. I'm going to reread some of these sections later, just out of my own curiosity, but yeah, introduction. So yeah, this is about SQL. Examples in this manual can be found in the PostgreSQL source documentation. To use those files, first change to that directory and run make, then you /i basics.tutorial. So it will be a problem. I will not be able to access it from this system. Where is cd PostgreSQL, cd src tutorial, make. There is no /user/bin. Cool. I have those, but make. Make chmod a plus rx star.sql. /i/home/string/code learning PostgreSQL PGSQL slash PostgreSQL slash SRC slash tutorial slash basics.sql. Yeah. Maybe. Slash home slash Postgres. Sudo chmod and Postgres slash home slash Postgres slash SQL. That sort of works. Yep. /I basics.sql. Cool. It has loaded the samples. So, Postgres is a relational database management system. It is a system for managing data stored in relations. A relation is essentially a mathematical term for a table. The notion of storing data in tables is so commonplace today that it might seem inherently obvious, but there are a number of other ways of organizing databases. Files and directories on Unix-like operating systems form an example of a hierarchical database. A more modern development is the object-oriented database. Each table is a named collection of rows. Each row of a given table has the same set of named columns, and each column is of a specific data type. Whereas columns have a fixed row of each fixed order in each row, it is important to remember that SQL does not guarantee the order of the rows within the table in any way, although they can be explicitly sorted for display. Tables are grouped into databases, and a collection of databases managed by a single Postgres server instance constitutes a database cluster. Cool. You can create a new table by specifying the table name along with the column names and their types. You have actually sudo. I should not be doing that. ls and sudo and the conda slash home slash Postgres sudo chmod Postgres slash home slash Postgres sh. Export path is equal to $path / user local, that is PHP PGSQL / bin that works. ls sh PostgreSQL Python is a directory point. No. Cool. Install PGCLI, because although I said I like I really need tab completion for this thing. Source -rc activate PGCLI. Hey, libpq dot interesting. PG2 library. What is this running under? Socket /temp at port. PGCLI. Connect via a socket. PGCLI/h/tmp. Hey, that worked. Okay. Nice. This is a much better. PGCLI/h/temp. Nice. Yeah, I'm going to switch to this. Cool. Now let's say I want to list the tables. List tables is /dt plus /dt plus. You don't have any tables here, so let me create a table. Create table weather. I can't. Okay, thought I could put white space in. City varchar 80. Then temp low, integer, temp high, integer, trcp, real, date is date. Cool. Now if I try /dt plus, it tells me that there is a public schema called weather, which is a table and owned by Postgres. Nice. Size is 0, it has no description. So you can enter PGSQL and it allows you line breaks, but this does not for some reason. Interesting. Nice. Multi-line on. Oh, I like this thing. So, it will recognize that the command is not terminated until the semicolon. White space can be used freely in SQL commands. That means you can type the command a line differently than above, and even all in one line. 2 dashes are comments. Whatever follows them are ignored. SQL is case insensitive about keywords and identifiers, except when identifiers are double quoted to preserve the case, not done above. Varchar 80 is a data type that can store arbitrary character strings up to 80 characters in length. Int is the normal integer type. Real is the type for storing single precision floating point numbers. Date should be self-explanatory. Yes, the column of date is also named date. This might be convenient or confusing. You choose. Wow, this is super opinionated. PostgreSQL supports the standard SQL types: int, small int, real, double precision, char of n, varchar of n, date, time, timestamp, interval, as well as other types of general utility and a rich set of geometric types. PostgreSQL can be customized with an arbitrary number of user-defined data types. Consequently, type names are not keywords in the syntax except where required to support special cases in the SQL standard. This is interesting. The second example will store cities and their associated geographical locations. I'm just going to copy this and paste it. Oh, I forgot. Cool. The point type is an example of a dt plus. Cool. I can create another. A point type is a example of a Postgres specific data type. So this is not SQL standard. So yeah. Finally, it should be mentioned that if you don't need a table any longer and want to recreate it differently, you can remove it with the following command: drop table, table name. I'm not going to drop anything right now. Populating a table with rows. So if you want to insert values, you can do this. Insert into weather values. Well, type this. Type in this one. Insert into weather values. What's this? 46. 50. 0.25. I mean, that doesn't matter, but 27. Cool. Note that the data types use rather obvious input formats. Constants that are not simple numeric values usually must be surrounded by single quotes. The date type is actually quite flexible in what it accepts, but for this tutorial we will stick to the unambiguous format shown here. Yeah, please stick to this format. That's the ISO standard for dates. The point type requires a coordinate pair as input, as shown here. Copying and pasting. Cool. The syntax used so far requires you to remember the order of the columns. An alternate syntax allows you to list the columns specifically. So you can tell which order you want to put stuff in. I mean, it's more work, but it works. You can list the columns in different order if you wish, or even omit some columns. If the precipitation is unknown, you can do this. Many developers consider explicitly listing the columns better style than relying on the order implicitly. Please enter all the commands shown above so you have some data to work with in the following sections. You could also have used copy to load large amounts of data from flat text files. This is usually faster because the copy command is optimized for this application while allowing less flexibility than insert. So you could copy weather from a text file, where the text file usually has all the SQL commands. SQL commands? Would it? Must be available on the machine, not the client, since the backend process reads the file directly. You can also read more about the copy command. Oh wait. If you use the copy command, it must be on the machine running the backend process, not on the client. So if I was connecting to PGCLI from another host, that would not have worked. Alright. Querying a table. If you want to query a table, you have to let's select star from weather. There you go. You have data, and here you have no precipitation data for this city. if you wanted all the columns explicitly, you name all the columns explicitly in the order that you want. You can also write expressions, not just simple column references. So wait, no, sorry. So yeah, you can do this, the average temperature. It also give you 3 rows, and yeah, this also, fun thing it did is, instead of this calculation, it also renamed this as average temperature. If I wanted, I can remove this stuff. So it will just put random question, column question. It doesn't say what it was. So there you go. And let's say you want a specific row where some condition was satisfied. You have that too. You can request that it be ordered by something. You can order it. So yeah, these 2 columns could be in any order. So you can also say, give me a distinct city. So it tells you the distinct cities. You want distinct city from weather, but you want to order by the city name. You can do that too, but there's not much of a difference. Select star is useful for off-the-cuff queries. It is widely considered bad in production code, since adding a column to the table would change the results. And yeah, so in some database systems, including older versions, the implementation of distinct automatically orders the rows, and so order by is unnecessary. But this is not required by the SQL standard, and current PostgreSQL does not guarantee that distinct causes the rows to be ordered. So joins between tables. Thus far, queries have only accessed one table at a time. Queries can access multiple tables at once, or access the same table in such a way that multiple rows of the table are being processed at the same time. A query that accesses multiple rows of the same or different tables at one time is called a join query. As an example, say you wish to list all the weather records together, yada 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 yada. I mean, yeah, there's only a conceptual model. The join is usually performed in a more efficient manner than actually comparing each possible pair of rows, but this is invisible to the user. So, because here, the tutorial actually claims that we have to compare the city column to each column to see which are the matching rows. But this doesn't actually do it that way. So if you want to do it here, you can say select star from weather and cities. You can do this. It has joined to this thing. But there is a problem. There is no result row for Hayward. That is because there's no matching entry in the cities table for Hayward. So the join ignores the unmatched rows in the weather table. We'll see shortly how to fix that. There are also 2 columns containing the city name. You have these 2 columns containing the city name. This is correct because the list of the columns from the weather and table are concatenated. In practice, this is undesirable. So you'll probably want to list the output columns explicitly rather than list using star. So you had city name twice, city. So here you just say what you want. So attempt to determine the semantics of this query when the where clause is omitted. This is interesting. With this, select star from cities, select star from weather, and this, and it just joined this. Interesting. So it just filled in this value because it just did a 1:1 mapping between each of them. Because yeah, it had only one location value. Just put that location value everywhere. Makes sense. I mean, so you just said join 2 tables and add whatever column is here. So you just added it willy-nilly to all the rows. It makes total sense. So since the table column names had all different names, the parser automatically found which table they belong to. If there were duplicate column names in the 2 tables, you would need to qualify the column names to show which one you meant. As in, you would have to do this. You have to explicitly say which column and where. You say weather.city, weather.temp low, weather.temp high, weather.precipitation, weather.date, cities.location. From this thing, where city.name is equal to weather.city. So great. It is widely considered good practice to qualify all column names on a join query so that the query won't fail if a duplicate column name is added to one of the tables. Join queries of the kind seen thus far can also be rewritten in this alternate form. Select star from weather, inner join. Oh yeah, you have this. It's the same thing, there's no difference. This syntax is not as commonly used because it's easier, the previous one is easier to read. Now we'll figure out how to add the Hayward records back in. What we want the query to do is scan the weather table and for each row find the matching cities row. If no matching row is found, we want some empty values to be substituted for the cities table column. This kind of query is called an outer join. The joins we have seen so far are inner joins. The command looks like this. Select star from weather, left outer join cities on. Somebody had once told me a very nice way of remembering outer and inner joins. The funny thing is it comes from this. This query is called a left outer join because the table mentioned on the left of the join operator will have each of its rows in the output at least once. Whereas you say left outer join when you don't want the left side left behind. Yeah, that's what he mentioned. It's been stuck in my head. So, whereas the table on the right side will only have those outputs that match some row on the left side. When outputting a left table row for each, for which there is no right table side, empty values are substituted. There are also right outer joins and full outer joins. Try to find out what those do. So nothing on the right side is left behind, and anything on the left behind is left behind. So on neither side. Let's say insert into cities values. Instead of saying San Francisco, let me say Bangalore. I'm just going to say 0, 0 instead. So if I did this, now there is a null column even here. But if this had been a right join, you have the Hayward column is gone because I did not ask it to keep whatever is on the left. I said don't leave behind anything on the right side. So it had that. So it added this in. Alright. So we can also join a table against itself. This is called a self-join. As an example, suppose we wish to find all the weather records that are in the temperature range of other weather records. We need to compare the temp low and the temp high columns of each row to the temp low and temp high columns of the other rows. We can do this with the following query. Select W1. Well, W1 is weather and W2 is also weather. So select weather temp low as low, weather temp high as high, temp low as low. So you're saying you're trying to find a value wherein the temp low is higher than the temp low for this one. So this value is higher, and for this value is higher again. So we have one of those. But I'm actually confused here. Temp low is lower than temp low and temp. Oh, for both those conditions. Yeah, that makes sense. Here we have relabeled the weather label, weather column as W1 and W2. So you can also use these kind of aliases in other things. You can also say select star from. You can also say this. It's a nice thing. So next, aggregate functions. You have aggregate functions in SQL. So let's say you want to compute a single result from multiple input rows. For example, there are aggregates to compute the count, sum, average, whatever. So you can say select max of temp row. Cool. You have this. You also want to say where that reading appeared. So you can't do this where you can't do this because the aggregate function cannot be used in the where clause. See, aggregate functions are not allowed in where, so you can't use that. However, you can instead say use a subquery. So in the where you can put another query, and there you go, you have the value. So aggregates are also very useful in combination with group by clauses. You can get the maximum low temperature observed in each city like so. So you say max low of this, group by the city. So it says the maximum low value. You can also say having. You have a you say select city and the maximum of the temperature wherein this has lower than this. Then you have, if you only care about cities whose names begin with an S, the like operator does pattern matching and is explained in section 9.7. That's going to be interesting. It is important to understand the interaction between aggregates and SQL's where and having clauses. The fundamental differences between where and having is where selects input rows before groups and aggregates are computed. Thus, it controls which rows go. One second. Which rows go into the aggregate computation, whereas having selects group rows after groups and aggregates are computed. Thus, the where clause must not contain aggregate functions. It makes no sense to try to use an aggregate to determine which rows will be inputs to the aggregates. On the other hand, the having clause always contains aggregate functions. Strictly speaking, you are allowed to write a having clause that doesn't use aggregates, but it's seldom useful. The same condition could be used more efficiently at the where stage. In the previous example, we apply the city name restriction where since it needs no aggregate. This is more efficient than adding the restriction to having, because we avoid doing the grouping and aggregation calculations for all the rows that fail the where clause. Nice. Updates. You can update existing rows using the update command. Suppose you discover the temperature readings are all off by 2 degrees after November 29th or November 28th. You can correct the data as follows. Update weather. Set temp high is equal to temp high minus 2, temp low is equal to temp low minus 2, where date is greater than this value. And then you say select star from weather, and that is it. You have increased everything. Like if you go up and see, you can see that the values were 46, 50, 43, 57. So the 43, 57, which was on the 28th, after the 28th of November, got updated. So fine, deletions. How do you delete a row? You can delete a row. You can just say I want to delete this one row. That's it. And this is something that PGCLI does. It actually tells you that you're going to run a destructive command. It tells you also a bulk command. So this is one of the reasons why I like this tool. So there you go. Your call. You deleted one. So you can also say delete from table name. So delete from table name will just truncate the entire table. I'm not running that right now. Right, advanced features, chapter 3. I am cool. 1 hour 42 minutes. I'm actually wondering what is a good stopping point for today. I thought I'll do it till the midnight because I am free. Wait. Where is... So this is part 1. I want to finish the tutorial. But I want to also do a section of the SQL language. I want to do a portion of this so that tomorrow I can do more sections. I want to do at least till chapter 7 of this thing. So if I finish until chapter 7 or chapter 8, that should be a good stopping point for today, I think. Good. Advanced features. Okay, now we'll discuss some advanced features of SQL that simplify management and prevent loss or corruption of your data. We'll look at some PostgreSQL extensions. It will refer to examples found in chapter 2 to change or improve them, so it will be useful to have read it. Some examples will also be found in advanced.sql in the tutorial directory. This file contains some sample code to load, which is not repeated here. Refer to section 2.1 for how to use the file. That is great. Right. So, advanced.sql. So this is the SQL file that is in advanced. It has some data here. Cool. Insert into cities. Why does it drop the table? Sure. I mean, why not? Next one. We have foreign keys. Cool. I'll be back in 10 minutes. Yep. Sorry. I had to record also. Recall the weather and cities table from chapter 2. Consider the following problem. You want to make sure that no one can insert rows into the weather table that do not have a matching entry in the cities table. This is called maintaining a referential integrity of your data. In simplistic database systems, this would be implemented by first looking at the cities table to check if the matching record exists and then inserting or rejecting the new weather records. This approach has a number of problems and is very inconvenient. So PostgreSQL can do it for you. The new declarations of the table would be this. So I'm going to change. I didn't mention dropping the tables, by the way, which was very. You have the drop table syntax. Did we see that? I think we did. Yeah. Drop table cities. Yes, I do. Drop table weather. Yes. So I'm going to create first this. I created a table cities which has, now it says the city name is a primary key. Let's next. You have the weather. The weather also has this references city of city, and that's it. So this, try inserting an invalid record. I'm going to insert this. It's just trying to insert this value into the weather table. It's not possible because the key city is equal to Berkeley is not present in the table cities. So you have to insert it first there. So the behavior of foreign keys can be finely tuned to your application. We will not go beyond this simple example in this tutorial, but just refer you to chapter 5 for more information. Making correct use of foreign keys will definitely improve the quality of your database applications, so you're strongly encouraged to learn about them. Transactions. Transactions are a fundamental concept of a database of all database systems. The essential point of a transaction is that it bundles multiple steps into a single all or nothing operation. The intermediate, by the way, if you can hear that, that's my cat. The intermediate states between the steps are not visible to other concurrent transactions, and if some failure occurs that prevents the transactions from completing, then none of the steps affect the database at all. For example, consider a bank database that contains balances for various customers' accounts, as well as total deposit balances for branches. Suppose that we want to record a payment of $100 from Alice's account to Bob's account. Simplifying outrageously, the SQL commands for this might look like update accounts, set balance is equal to balance minus 100. We're updating, yeah. So update branches, set balance is equal to balance minus 100. So update accounts, set balance is equal to balance plus 100 for Bob, and then this thing. The problem is there are several different updates involved to accomplish this rather than a simple operation. Our bank's officers will want to be assured that either all of these will happen or none of them will happen. It would certainly not do for a system failure to result in Bob receiving $100, which was not debited from Alice. Nor would Alice long remain a happy customer if she was debited without Bob being credited. So the thing is, this entire thing needs to happen at once. Either you do all of them or you do none of them. Grouping the updates into a transaction gives us this guarantee. A transaction is said to be atomic. From the point of view of other transactions, it either happens completely or not at all. We also want a guarantee that once a transaction is completed and acknowledged by the database system, it has indeed been permanently recorded and won't be lost even if a crash ensues. Where did I say ensues? We also want a guarantee that it has been permanently recorded. If we are recording a cash withdrawal for Bob, we don't want any chance that the debit of his account will disappear in a crash just after he walks out the bank door. A transactional database guarantees that all updates made by a transaction are logged in permanent storage on disk before the transaction is reported complete. Another important property of transactional databases is closely related to the notion of atomic updates. When multiple transactions are running concurrently, each one should not be able to see the incomplete changes made by others. For example, if one transaction is totaling all the branch balances, it would not do for to include the debit from Alice's branch but not to credit Bob's branch, nor vice versa. So transactions must be all or nothing, not only in terms of their permanent effect on the database, but also in terms of their visibility as they happen. The updates made so far by an open transaction are invisible to other transactions until the transaction completes, whereupon all updates become visible simultaneously. In PostgreSQL, a transaction is set up by surrounding the SQL commands of a transaction with begin and commit commands. So our banking transaction would actually look like this. Begin, update account, set balance is equal to balance minus 100. Let's see, is there a balance table schema here? We don't, but this is an example, it's not relevant really. So if you have a begin and then you have a commit. So if partway through the transaction we decide we do not want to commit, we just notice that the balance went negative, we can issue the command rollback instead of commit, and all our updates will so far be cancelled. Postgres actually treats every SQL command as being executed within a transaction. If you do not issue a begin command, then each individual statement has an implicit begin and, if successful, commit wrapped around it. A group of statements surrounded by begin and commit is sometimes called a transaction block. Some clients use begin and commit commands automatically so that you might get the effect of transaction blocks without asking. Check the documentation for the interface you're using. SQL Alchemy does this for Flask, by the way, so you have to explicitly commit everything. So it's possible to control the statements in a transaction in a more granular fashion through the use of save points. Save points allow you to selectively discard parts of transactions while committing the rest. After defining a save point with save point, you can, if needed, roll back to the save point with rollback to. All the transactions database changes between defining the save point and rolling back to it are discarded, but changes earlier than the save point are kept. After rolling back to a save point, it continues to be defined. You can roll back to it several times. Nice. Conversely, if you're sure you won't need to roll back to a particular save point again, it can be released so the system can free some resources. keep in mind that either releasing or rolling back to save point will automatically release all save points that were defined after it. All this is happening within the transaction block, so none of it is visible to other database systems. When and if you commit the transaction block, all committed actions become visible as a unit to other sessions, while the rollback actions never become visible at all. Remembering the bank database, suppose we would debit $100 from Alice's account and credit Bob's account, only to find later that we should have credited Wally's account. We could do using save points like this. Begin, do some stuff, create a save point, do some more stuff, oops, roll back to the original save point, update stuff, then commit. This is nice. I mean, it looks like a video game. So, this example, of course, is oversimplified, but there are a lot of control possible to a transaction block through the use of save points. Moreover, rollback to is the only way to regain control of a transaction block that was put in aborted state by the system due to an error, short of rolling it back completely and starting again. So, window functions. A window function performs a calculation across a set of table rows. By the way, these guys said that the advanced SQL file has all this. It does not. This is just oh, this is inheritance. SQL. And then complex.SQL. New type. Then funcs.SQL. Alright, I was just taking a minute to fix something. Should be fixed on a momento. refresh. Come back to pgcli -h/temp-u Postgres. Huh. This has a Vim mode too. I need it too. Cool. My DB plus. Cool. Sorry about that. I had to feed my cat. Cool. So, where am I? A window function. window function performs a calculation across a set of table rows that are somehow related to the current row. This is comparable to the type of calculation that can be done with an aggregate function. However, window functions do not cause rows to become grouped into a single output row like non-window aggregate calls would. Instead, the rows retain their separate identities. Behind the scenes, the window function is able to access more than just the current row of the provided result. Here is an example. Select this over partition by department name from employee salary. How would I build this? This is window. This tables, max low, weather, and funcs.sql. This creates a function, but the first three output columns come directly from the table employee salary, and there is one output row for each row in the table. I have a question actually. Advanced these are I'm trying to see where the examples are coming from. Now let me go back there. Because the employee table, I did not write this. Alright. So, I'm actually trying to see where this data set is coming from. These guys are showing me results, but I do not have this. It would have been nice if I had this result data. Is it coming from? It's not clear. I should email these guys and ask them where the data is coming from. Or is it possible that they're... oh god. What? I think this is like a hypothetical scenario instead. It's not really a actual data set which is present here, but still. you say average data partition over department name. So you have a department name, but so you select each employee's average salary. The first three output columns come directly from the employee's salary, but there is one output row for each row in the table. The fourth column represents an average taken across all rows. Oh, so it's comparing that average. That has the same department name as the current row. So it's like grouping by this, but then taking an average over that. Nice. This is actually the same function as a non-window average aggregate, but the over clause causes it to be treated as a window function and computed across the window frame. The window frame is, when you say partition by department name, it gets grouped by that and averaged over that. A window function call can always contains an over clause directly followed by the window function's name and arguments. Hello. Hear me. My cat wants to try coming here for some goddamn reason. Come. No. I see the camera. What? He is not happy. He's a very yeah. Yeah. I was away from him the entire day, so now he's finally feeling cuddly. What? Okay. Say bye. Cool. Back to this. So, a window function call always contains an over clause directly following the window function's name and arguments. This is what syntactically distinguishes it from a normal function or a non-window aggregate. The over clause determines exactly how the rows of the query are split up for processing by the window function. The partition by clause within the over divides the rows into groups or partitions that share the same values of the partition by expressions. For each row, the window function is computed across the rows that fall into the same partition as the current row. You can also control the order in which rows are processed by window functions using order by within an over. The window order by does not even have to match the order in which the rows are output. Here is an example. Select department name, employee number, salary, rank over this. So you order by. Interesting. I really need the where is the test? Panda activate PGCLI. Oh, sorry. PGCLI -head /10 -u stress text. PGCLI -u Postgres -head /temp -test /dt. There's something here. I have no clue where this guy got the data set. Salary data set. window. That's where this is. All of this information is from /test/regress/sequel/window.sql. cd/test regress. What was that? Expected SQL. Margin into salary as window.out. Okay, this is both SQL and it is the output. So that's where they're using it from. But the test database should have had PostgreSQL test database. Please skip. Yeah. Cool. I'm not going to bother about this. So window functions are permitted only in the select list and in the order by clause. They are forbidden elsewhere, such as in group by, having, and where clauses. This is because they logically execute after the processing of those clauses. Also, window functions execute after non-window aggregate functions. This means it is valid to include an aggregate function call in the arguments of a window function, but not vice versa. If there is a need to filter or group rows after the window calculations are performed, you can use a subselect. For example, select department name, employee number, salary, enroll date from, wow. You rank this over, you partition here. So rank is the window function which is happening here. And from this, you want to select the department name, this, and the enroll date. But why did you want to use order by salary descending? Position, what is position? So the rank over this is the position. So you're selecting the top two of these, rather the rank, whichever has a rank of less than 3. This is nice. My cat is trying to attack my laptop charger. Problems of having a cat. So, when the query involves multiple window functions, it is possible to write out each one with a separate over clause, but this is duplicative and error prone if the same windowing behavior is wanted for several functions. Instead, each windowing behavior can be named in a window clause and then referenced in over. For example, you have salary over W, average salary over W, this W, but you define the window itself as partition by department name ordered by salary. Wow. That's nice. There are options to define window frame in other ways, but this tutorial does not cover them. See section 4.2.8. I'm going to come back to these. Inheritance. Inheritance is a concept from object-oriented databases. It opens up interesting possibilities of database design. Let's create two tables, a table cities and a table capitals. Naturally, capitals are also cities, so you want some way to show the capitals implicitly when you list all cities. If you're really clever, you might invent some schema like this. Create table capitals, name, population, elevation, state. You have this and this. You have capitals, non-capitals, and then you say create view cities and this. This is fine. You're creating a view on top of capitals and non-capitals, and you have all of this. A better solution would be create a table for cities. You have name, populations, elevation, and then you create a capital which inherits cities, but it also has the value of state. So it defines which state it is the capital of. In this case, a row of capitals inherits all columns for name, population, and elevation from its parent cities. The type of column name is text, a native PostgreSQL for variable length character strings. That's because all of this is defined. The capitals table has an additional column state, which is char2, so you would have state abbreviation. In PostgreSQL, a table can inherit from 0 or more tables. For example, the following query finds names of all the cities, including state capitals, that are located at an elevation over 50 feet. So you say select name from cities where elevation is greater than this, it will return this. On the other hand, the following query finds all the cities that are not state capitals and are situated at an elevation over 500 feet. Select, you see only cities. So if you say select from cities, it selects from cities and everything it inherits. However, here you say something which are not state capitals where the elevation is greater than 500. Here the only clause indicates that the query should only be run on the cities table and not tables below the cities table in inheritance hierarchy. Many of the commands that we have already discussed, select, update, delete, support this only notation. Although inheritance is frequently useful, it has not been integrated with unique constraints or foreign keys, which limits its usefulness. 5.10 for more detail. Interesting. Conclusion. It has many features not touched upon on this introduction, which has been oriented towards newer users of SQL. These features are discussed in more detail in the remainder of this book. If you feel you need more introductory material, please visit the website for more resources. Next part, the SQL language. Great. I am going to first update Cool. This part describes the use of the SQL language in Postgres. I am going to go here, notes, so completed. Amy, what's up? No. SQL syntax. Hello. How am I supposed to read if you are sitting here? The middle part lists all the data. Hey, no, you are not going behind the monitor. Come on. Alright, the information in this part is arranged so that a novice user can follow it from start to end to gain a full understanding of the topics without having to refer forward too many times. The chapters are intended to be self-contained so that advanced users can read the chapters individually as they choose. The information in this part is presented in a narrative fashion and in topical units. If you want a complete description of a particular command, you should see part 6. You should know how to connect to a Postgres database and issue SQL commands. Readers that are unfamiliar with these are requested to encouraged to read part 1 first. SQL commands are typically entered using the Postgres T-SQL, but other commands have similar functionality as well. Great. Chapter 4. 4.1 lexical structure. So, a SQL input consists of a sequence of commands. A command is composed of a sequence of tokens terminated by a semicolon. The end of the input stream also terminates a command. Which tokens are valid depends on the syntax of the particular command. A token can be a keyword, an identifier, a quoted identifier, a literal or constant, or a special character symbol. Tokens are normally separated by white space, but need not be if there is no ambiguity, which is generally only the case if a special character is adjacent to some other token type. For example, the following is syntactically valid SQL input. Select star from my table, update table, set A is equal to 5, insert into my table values 3, hi there. This is a sequence of 3 commands, 1 per line, though this is not required. More than 1 command can be on a single line, and commands can usefully be split across lines. Additionally, comments can occur in SQL input. They are not tokens. They are effectively equivalent to white space. The SQL syntax is not very consistent regarding what tokens identify commands and what are operands or parameters. The SQL syntax is not very consistent regarding the first few tokens are generally the command name. So in the above example, we would usually speak of select, an update, and an insert command. But for instance, the update command always requires a set token to appear in a certain position, and this particular variation of insert also requires values in order to be complete. The precise syntax rules for each command is described in part 6. Identifiers and keywords. Tokens such as select, update, or values in the example above are examples of keywords. That is, words that have fixed meaning in the SQL language. The tokens my table and A are examples of identifiers. They identify names of tables, columns, or other database objects depending on the command they are used in. Therefore, they are sometimes simply called names. Keywords and identifiers have the same lexical structure, meaning that one cannot know whether a token is an identifier or a keyword without knowing the language. A complete list of keywords can be found in Appendix C. SQL identifiers and keywords must begin with a letter A to Z, but also letters with diacritical marks and non-Latin letters, or an underscore. Subsequent characters in an identifier can be letters, underscores, digits, or dollar signs. Note that dollar signs are not allowed in identifiers according to the letter of the SQL standard, so their use might render applications less portable. The SQL standard will not define a keyword that contains digits or starts off or ends with an underscore. So identifiers of this form are safe against possible conflict with future extensions of the standard. Nice. The system uses no more than name data length -1 or bytes of an identifier. Longer names can be written in commands, but they will be truncated. By default, name data len is 64, so the maximum identifier len is 63 bytes. This makes sense. If this limit is problematic, it can be raised by changing the name data len constant in /src/include /pgconfig manual.h. Let me see. Then include /pg_config _manual.h /name data len. There it is. Makes sense. So if you increase this and recompile, you have a version of Postgres which has a higher value of nice. Should not have insanely long table names, but column names, but you do you. Keywords and unquoted identifiers are case insensitive. Therefore, update my table set. By the way, if I do this, this is slightly better. Update my table set A is equal to 5 can be rewritten, can equivalently be written as update my table set A is equal to 5. Oh, please don't do this. A convention often used is to write keywords in uppercase and names in lowercase. There is a second kind of identifier, the delimiter identifier or quoted identifier. It is formed by enclosing an arbitrary sequence of characters in double quotes. A delimited identifier is always an identifier, never a keyword. So select could be used to refer to a column or table named select, whereas an unquoted select would be taken as a keyword and would therefore okay, so if you quote a key identifier, you can use whatever the hell you want. Invoke a parser error when used when a table or column name is expected. The example can be written with quoted identifiers as update my table set A is equal to 5. Cool. Quoted identifiers can contain any character except the character with code 0. To include a double quote, write 2 double quotes. Oh god, no. Not a backslash? That's annoying. This allows constructing table or column names that would otherwise not be possible, such as ones containing spaces or ampersands. The length limitation still applies. Good. But does the length limitation include the... It should not. That should not. Quoting an identifier also makes it case sensitive, whereas unquoted names are always folded to lowercase. For example, the identifiers foo, and quotations are considered the same by Postgres, but foo and foo are different from these three and each other. So you force case sensitivity. The folding of unquoted names to lowercase in Postgres is incompatible with the SQL standard, which says that unquoted names should be folded to uppercase. Thus, foo should be equivalent to foo and not foo, according to the standard. If you want to write portable applications, you are advised to always quote a particular name and never quote it. So don't use a mix of both of these. Got that? A variant of quoted identifiers allows including escape Unicode characters identified by their quote points. This variant starts with U ampersand. Immediately, not a Unicode name. Immediately by the opening double quote without any spaces in between. For example, U ampersand double quotes foo. This creates an ambiguity in the operator ampersand. Use spaces around the operator to avoid this problem. Inside the quotes, Unicode characters can be specified in escape form and a 4-digit hexadecimal code point number, alternatively a backslash followed by a plus sign followed by a 6-digit hexadecimal code number. Data could be written as, oh great, wow, TM, this works. The following less trivial example writes the Russian word slon, elephant, in Cyrillic letters. You have this, wow. If a different escape character than backslash is desired, it can be specified using the uEscape clause after the string. For example, oh wow, okay, good. The escape character can be any single character other than a hexadecimal digit, the plus sign, or a single quote, or a double quote, or a white space character. Note that the escape character is written in single quotes, not double quotes. Sorry, after you escape. The escape character itself is in single quotes. Nice. To include the escape character in the identifier literally, write it twice. Either the 4-digit or the 6-digit escape form can be used to specify UTF-16 surrogate pairs to compose characters with code points larger than U plus 4Fs. Although the availability of the 6-digit form technically makes this unnecessary. Surrogate pairs are not stored directly, but are combined into a single code point. If the server encoding is not UTF-8, the Unicode code point identified by one of these escape sequences is converted to the actual server encoder. An error is reported if that's not possible. Constants. There are 3 kinds of implicitly typed constants in Postgres: strings, bit strings, and numbers. constants can also be specified with explicit types, which enable more accurate representation and more effective handling by the system. These alternatives are discussed in the following subsections. Alright. String constants. A string constant in SQL is an arbitrary sequence of strings bounded by single quotes. For example, this is a string. Ouch, I dropped my bottle. To include a single quote character within a single constant, within a string constant, write two single quotes. For example, that's two string constants that are only separated by white space with at least one new line are concatenated and effectively treated as if the string had been. This is something at least that I can do. Yep. But this is separate. Nice. This slightly bizarre behavior is specified by SQL. Postgres is just following the standard. They're just saying, don't blame us. String constants with C-style escapes. Yes, please. Postgres also accepts escape strings, which are. How about that? Select. Does that work? No, that doesn't work. Oh. This makes it harder to read some of these. You have /b, /n, /t, you have all of these, but however I can't escape the quote, which is weird. So interesting. Any other character following by a backslash is taken literally. Thus, to include a backslash character, write two backslashes. Also, a single quote can be included. Wait. It says it can be, but that does not seem to be valid. That is. See? Ow! Oops. Silly me. I had to write an E before this. So explicitly say or escaping this. Fun. But looks like PGCLI does not know that you can do this. Good. This is a bug then. But this is not in the SQL standard, it's an extension to the SQL standard. Well, fair enough. When continuing an escape string across lines, write E only before the first opening quote. Within an escape string, a backslash character begins a C-like backslash. Yeah, this is done. It's your responsibility that the byte sequences you create, especially when using the octal or hexadecimal escapes, compose valid characters in the server character encoding cell. Not bad. This actually looks like it was printing. Yep, this works. Nice. A useful alternative is to use Unicode escapes or the alternate Unicode escape syntax explained in 4.1.2.3. Then the server will check that the character conversion is possible. If the conversion parameter standard conforming strings is off, then PostgreSQL recognizes backslash escapes in both regular and escape string constants. However, as of Postgres 9, the default is on. Standard conforming strings. I mean, sure, this is more standards compliant, but might break applications which rely on the historical behavior, where backslash escapes are always recognized. As a workaround, you can set this parameter to off, but it is better to migrate away from using backslash escapes. If you need to use a backslash escape, write the string constant with an E. In addition to standard conforming strings, the configuration parameters escape string warning and backslash quote govern treatment of backslashes and string constants. The character with code 0 cannot be a string constant. And what? Huh. Very nice. White spaces. Yeah, that is good. String constants with Unicode escapes. You have this stuff. U ampersand. Didn't we see this before? U ampersand. Why do I feel like I've done this before? All of this was in the basics. It only works when standard conforming strings is on, because otherwise SQL injections and similar security. So if this is off, this syntax will be rejected with an error message. Okay. Dollar quoted string constant. Oh God, no. How did these guys go from this to a dollar sign? Backslash escape would have been. It's like seeing some alternate world where you have yeah, sure, lions, horses. Oh wow. So you put some everything between the double dollar signs is ignored. It is possible to nest dollar quoted string constants by choosing different tags at each nesting level. This is most commonly used in writing function definitions. For example, function. Wait. What is this? You agree? Oh man, it's too late in the night to be looking at these kind of statements. Oops. To nest dollar quoted string constants by choosing different tags at each nesting level. Tag, if any, of a dollar quoted string follows the same rules as an unquoted identifier, except that it cannot contain a dollar sign. Tags are case sensitive, so tag string content tag is correct, but tag string content tag is not. A dollar quoted string that follows a keyword or identifier must be separated by it for a white space. Otherwise, dollar quoting delimiters would be taken as part of the preceding identifier. Dollar quoting is not part of the SQL standard, but it is a more convenient way to write complicated string literals than the standard compliant single quote. Really, I have some beef to pick with these people. It is particularly useful when representing string constants inside other constants, as is often needed in procedural function definitions. With single quote syntax, each backslash in the above would have to be written as 4 backslashes. I have to cede to these guys. I mean, compared to the fact that we have 4 backslashes, this is a better way of doing it, but I'm not happy that this is the better way of doing it. Which would be reduced to 2 backslashes in parsing the original string constant, and then to 1 when the inner string constant is reparsed during function execution. Bit string constants look like regular string constants with an uppercase B immediately before it, so can be specified in hexadecimal notation using a leading X. It is equivalent to writing a bit constant with 4 binary digits for each hexadecimal. Both forms of bit string constant can be continued across lines in the same way as regular string constants. Dollar quoting cannot be used in a string constant. Numeric constants are accepted in these forms. Digits, you have digits with more digits and E plus or minus digits, or you have some digits, decimal and this thing, or you have digits with an E and this thing. One digit must be before or after the decimal point if one is used. What happens if you have 0.1? Select 0.1. 1 point. 1E3. 1E plus 3. 1E minus 3. Cool. There cannot be any spaces or other characters embedded in the constant. Note that any leading plus or minus sign is not actually considered part of the constant. There is an operator applied to the constant. There are some examples of valid numeric constants. There are some examples. These are some examples. Yeah, you have all of this. Don't you have? Now that's interesting. I have no idea how this happened. Nice. Select 10 as number. Instead, you can do this or what's that? Submit as if you're using parentheses. Select 10. Ah, I don't know that. No parentheses required. A numeric constant that contains neither a decimal point nor an exponent is initially presumed to be type integer if its value fits in type integer. Otherwise, it is presumed to be type bigot if its value fits in type bigot. Otherwise, it is taken to mean type numeric. Constants that contain decimal points and or exponents are always presumed to be type numeric. The initially assigned data type of a numeric constant is just a starting point for the type resolution algorithms. In most cases, the constant will be automatically coerced to the most appropriate type depending on context. When necessary, you can force a numeric value to be interpreted as a specific data type by casting it. For example, you can force a numeric value to be treated as type real by writing real. Constants that contain decimal points are always presumed to be type numeric. The initially assigned data type of a numeric constant is a starting point for the type resolution arguments. In most cases, the constant will automatically be coerced to the most appropriate type depending on context. When necessary, you can force a numeric value to be interpreted as a separate specific type. Yeah, this makes sense now. I'm okay with this syntax, by the way. These are actually just special cases of the general casting notations discussed next. Constants of other types. You have type string, string type. Yeah, what happened to this? Cast string as type. The string constant's text is passed to the type name. Oh, okay. Now, sorry, what am I even doing? I think I'm too sleepy to do this. The colon, cast, and function call syntaxes can also be used to specify runtime conventions of arbitrary expressions. To avoid syntactic ambiguity, the type string syntax can only be used to specify the type of an array constant. Cast syntax conforms to SQL. The type syntax is a generalization of the standard. SQL specifies the syntax only for a few data types, but Postgres allows it for all types. The syntax with : is historical PostgreSQL usage, as is the function call syntax. An operator name. So you can also select cast 10 as input. int4 64. I don't have a real, so interesting. Excuse me. The string constant's text is passed to the input conversion routine for the type called type. The result is a constant of the indicated type. The explicit typecast can be omitted. If there is no ambiguity as to the type the constant must be. For example, when it is directly assigned a table column, in which case it is automatically coerced. The string constant can also be written using either regular SQL notation or dollar quoting once again. It is also possible to specify a type coercion using a function-like syntax. This makes sense. Now all of this makes sense. Operators. Like we read before, operator name has this limitation, but use there are a few restrictions on operator names, however. Dash and slash star cannot appear anywhere in an operator name since they'll be taken as the start of a comment. A multiple character operator name cannot end in plus or negative unless the name also contains one of the following characters. @ hyphen is an allowed operator name, but star hyphen is not. This restriction allows Postgres to pass SQL compliant queries without requiring spaces between tokens. When working with non-SQL standard operator names, you will usually need to separate adjacent operators with spaces to avoid ambiguity. If you have defined a prefix operator named @, you cannot write x star @y. You must write x star space @y to ensure that Postgres reads it as two operator names and not one. What does it do with it? Special characters. Some characters that are not alphanumeric have a special meaning that is different from being an operator. Details on the usage can be found at the location where the respective syntax element is being described. This section only exists to advise their existence and summarize the purposes of these characters. A $sign, dollar, followed by digits is used to represent a positional parameter in the body of a function definition or a prepared statement. In other contexts, the $sign can be a part of an identifier or a $quoted string constant. Parentheses have their usual meaning to group expressions and enforce precedence. In some cases, parentheses are required as a part of a fixed syntax of a particular SQL command. Brackets are used to select the elements of an array. Normally. Commas are used in some syntactical constructs to separate the elements of a list. The semicolon terminates a SQL command. It cannot appear anywhere within the command except within a string constant or quoted identifier. The colon is used to select slices from arrays. In certain SQL dialects, such as embedded SQL. Wait, what? What the hell is embedded SQL? Is a method of combining the computing power of a programming language and the database manipulation capabilities of SQL. Are SQL statements written inline in program source code? That embedded. Okay. No, I'm definitely too tired for this. The asterisk used in some contexts to denote all fields of a table row or composite value. It also has a special meaning when used as an argument of an aggregate function, namely that the aggregate does not require any explicit parameter. The period dot is used in numeric constants and to separate schema, table, and column names. A column is a sequence of characters beginning with double dash and extending to the end of a line. Alternatively, C-style block comments can be used. Multi-line comment. You have this with nested. You have nested comments. Great. Where the comments begin with a star and extend to the matching reference of */. Can nest, but unlike C, so that one can comment out large blocks of code that might contain existing block comments. A comment is removed from the input stream before further syntax analysis and is effectively replaced by white space. Operator precedence. So the operator precedence is the column name separator, then you have typecasting, then you have array element selection, you have unary, exponentiation, multiplication, abstraction, subtraction, any other native or user defined operators. Then you say range containment between n like, I like, similar. You have comparison operators, is null, is not null. So not and or modamas, right? No, that doesn't hold. The operator precedence rules also apply to user-defined operators that have the same names as the built-in operators mentioned above. If you define a plus operator for some custom data type, it will have the same precedence as the built-in plus operator, no matter what yours does. When a schema qualified operator name is used in operator syntax, as for example in this, the operator construct is taken to have the default precedence shown in table 4.2 for any other operator. This is true no matter which specific operator appears in the operator. Postgres versions before 9 use slightly different operator precedence rules. In particular, less than equal to, greater than equal to, not equal to used to be treated as generic operators. This test used to have higher priority, and not between and relative constructs acted inconsistently, being taken in some cases as having the precedence of not rather than between. These rules were changed for better compliance with SQL standard and to reduce confusion from inconsistent treatment of logically equivalent constructs. In most cases, these changes will result in no behavioral change, or perhaps in no such operator failures, which can be resolved by adding parentheses. However, there are corner cases in which a query might change behavior without any parsing error being reported. Nice. Value expressions. So this is what we're going to do next. But not right now. I'm going to So this chapter has been a little more involved than what we have done so far. Just the lexical structure, and that makes sense. This showed us the grammar of SQL, so to speak. The grammar, how the language is structured and everything, which was quite interesting actually. This thing is too long for me to do right now. I'm going to stop here. This is a logical stopping point. Cool. I will be back tomorrow and make that 10:30 a.m. Alright. This was fun. I'm not sure if anyone else had fun. I did.